And welcome to using the basic limit properties. So we did a little of this in our basic limit properties video. The idea is basically we can use the basic limit properties to solve much more complicated limits just by slowly breaking the functions down. So we can use the basic limit properties to evaluate more complicated limits. By breaking the functions down. So for example, if we wanted to take the limit as x approaches 3 of 2x squared minus 5x plus 3, we could break this down. So by our addition and subtraction property, this is the limit as x approaches 3 of 2x squared minus the limit as x approaches 3 of 5x plus the limit as x approaches 3 of 3. So this first step, we are using our sum and difference property. Then from here, we can go ahead and pull out our constants. So we have 2 times the limit as x approaches 3 of x squared minus 5 times the limit, or our scalar multiples, sorry, 5 times the limit as x approaches 3 of x plus the limit as x approaches 3 of 3. So on this step, what we did was we used the scalars. Then if we wanted, we could pull out our square. So this is 2 times the limit as x approaches 3 of x, and we are going to put that limit inside its square, minus 5 times the limit as x approaches 3 of x, plus the limit as x approaches 3 of 3. So on this stage, we are using powers. Now these first two are just the identity. So we have 2 times 3 squared minus 5 times 3, and then plus 3. So this was using the identity. As well as the constant. And we wind up getting 2 times 3 squared. We're looking at 2 times 9 or 18 minus 15 plus 3. And we wind up getting 6. Now, if we look at what we wound up with at the bottom, 2 times 3 squared minus 5 times 3 plus 3, that was actually just our polynomial we started with evaluated at x equals 3. So side note, so this is just 2x squared minus 5x plus 3 evaluated at x equals 3. So for another example, let's go ahead and look at the limit as x approaches -1 of x squared plus 2 over x plus 4. So to do this, we can split our limit as the limit as x approaches -1 of x squared plus 2 divided by the limit as x approaches -1 of x plus 4. So here we are using our quotient. Again, assuming that denominator does not go to 0. Then this becomes, we can split it out. I'm going to go quickly. So we have the limit as x approaches -1 of x, that whole thing squared, plus the limit as x approaches -1 of 2. And that is all being divided by the limit as x approaches -1 of x plus the limit as x approaches -1 of 4. So that's using our addition rule and our power rule for the numerator and just the addition rule for the denominator. Let me give myself just a little more space here. So this top now, we have the limit as x goes to -1 of x is just -1. That is being squared. And then we're taking the limit of a constant function, so we just get that plus 2. And then in the denominator, we have the identity again, so -1, and a constant again. So we have -1 squared is 1, plus 2 is 3. And -1 plus 4 is also 3. And we wind up getting 1. So again, what we wound up with here is just x squared plus 2 over x plus 4, what we started with, evaluated at x equals -1. So I didn't label here. From this step to this one, we were using both the sum and power. And then this last step here, we were doing identity and constant. So the reason I made my 2 notes in green here is that for both our polynomial we were working with and the rational function we were working with, it wound up that the limit was just the function evaluated at our target point. So for the limits of polynomial and rational functions, we can just cut straight to the answer. There's not much, we don't have to keep working through all these properties over and over and over again. So for polynomial function, p of x, p for polynomial, then what we wind up getting is that the limit as x approaches c of p of x is simply the polynomial evaluated at c. So for example, if we wanted to take the limit as x approaches 5 of negative x cubed plus 4x squared minus 3x plus 1. This is a polynomial. It's just made up of the identity function constants, powers, and sums and differences. We can just go ahead and evaluate this. So this is simply negative 5 cubed plus 4 times 5 squared minus 3 times 5 plus 1, or negative 125 plus 100 minus 15 plus 1, which winds up being negative 39 if I'm doing my arithmetic correctly. For rational functions, so where we have, say, p of x over q of x, here p and q are polynomials. Then we get that the limit as x approaches c of p of x over q of x is just p of c over q of c, just plugging in our value c, as long as q of c is not equal to 0. Dividing by 0 complicates things. So again, for a quick example, if we wanted the limit as x approaches 2 of x squared minus 5 over x squared plus 3x, we can just go ahead and plug in 2. So we have 2 squared minus 5 over 2 squared plus 3 times 2. And we get 4 minus 5, or negative 1, over 4 plus 6, or 11. Sorry, I have 10. So we have negative 1 over 10. So this makes our life a whole lot easier. We don't have to keep running through all of those different properties over and over and over again. We can just go ahead and evaluate the function at those specific points.